All right, now I think you're ready for some harder ones. This one looks a little more complicated, and I'm actually going to solve it two different ways. Most of the two solutions will be the same. The difference in the solutions comes from this negative sign. If you look at the formula sheet, there's two rules that are similar. Positive 1 becomes arc sine, negative 1 becomes arc cos. So when we look at my question here, I could take the 5 out and leave negative 1, or I could take the negative 5 out and leave a 1 here. And it'll give me two slightly different solutions. Let me show you. Let's try taking the negative 5 out. Negative 5 times the integral. I'm going to have 1 over, but I need to do something else in here. The formula sheet says I need a squared minus x squared. But I've actually got 9x squared. So I have to deal with this 9. To deal with this 9, I'm going to get 1/9 in here and factorise the 9 out. So it's going to be the square root of 9 times 1/9 minus x squared. Can you see what we did? We factorised the 9 and we're left with something minus x squared. Now this something has to be something squared. What is it? It's 1/3 squared. We can also move this root 9 because the square root of 9 is 3. Let me show you every line. In the second solution, the alternative, I might not show every line. This is going to be minus 5 times the integral of 1 over root 9 times 1/3 squared minus x squared dx. All I've done is split that 9 off. But now I've got root 9, I can take it out. I can make this root 9 be 3 and take it out. Minus 5 on 3 times the integral of square root of 1/3 squared minus x squared dx. Okay, now I can apply my rule. 1 over a squared minus x squared is arc sine of x on a. So that is minus 5 on 3 arc sine of x on, well, a is 1/3. Well, if I'm dividing by 1/3, that's the same as multiplying by 3. Arc sine 3x. And you may or may not put brackets around, it's up to you. Okay, what happens if I take out just the 5 and leave the negative behind? Then my integral, I probably should rewrite it if I'm going to be neat. Negative 5 over the square root of 1 minus 9x squared dx is going to be 5 times the integral of 1 over. Now I still need to do this thing because the other rule with the, what have I done wrong? Negative 1, I've got to leave my negative sign there, sorry. Now what's my rule say? Negative 1, I need a squared minus x squared. So I need to get rid of that coefficient of x squared. It's 9, so I'm going to take the 9 out. Square root of 9 times 1/9 minus x squared dx. Now this time I'm going to skip one step. This root 9 is going to become 3. It's on the bottom, so I'm going to have 5 on 3 times the integral of minus 1 over, now I should have what I want, square root of 1/3 squared minus x squared. And this should exactly match my rule. Okay, arc cos x on a. That is 5/3 arc cos x over 1/3. And again, dividing by 1/3 is the same as multiplying by 3. Forgot my constant. Both of these are valid answers. What's the relationship between them? Negative arc sine and arc cos. Do you remember those graphs we drew? Arc sine went this way and arc cos went that way, which means they could easily be negations of each other. However, the constants would be different. Again, it doesn't matter until we do a definite integral or we have an initial conditions. It doesn't matter about what the constant is. Either of these are perfectly useful solutions.